Hi everyone, we're doing the last set for SAT Practice Level 2 Algebra, and sorry it's a little messy here, but basically here's your equation. N can't be 3p because that would leave the denominator 0, so they want you to solve for p basically. They want it p on this side and everything else on the other. So if we can go ahead and kind of start here, what I want to do is go ahead and cross multiply this equation here, and you're going to get s, if I write this as s over 1, so s times n minus 3p equals n squared plus p, and go ahead and distribute, you get sn minus 3sp equals n squared plus p. Now since we're solving for p, I'm going to move everything over to one side, and you can either move it over to the left or the right. I'll go ahead and move it over to the right here. So I'm going to have Sn, I'm going to move him over to the left, and then I'm going to write him down and add him to both sides, each of those terms. Now we're solving for p, so what I'm going to do is factor out a p over here, and that's going to give you 1 plus 3sp equals Sn minus n squared. Now you divide both sides by 1 plus, so Sn minus n squared over 1 plus 3sp. Now, do we have it anywhere here? I have my s's too big here, so n squared, oh, it's right here, so the answer would be D. The only thing we did different is switch the, actually I don't know if it's D. Let's look. The answer to 8 is E, actually, and I didn't see E up here. So basically you factor out a negative here, which we could have done earlier. You factor out a negative and you're going to get negative n squared minus ns over 3s plus 1. Right? And that gives you your p. And I shouldn't have had the p here. Factored out a p, so just notice that. I know you all already noticed that. So that was wrong. So the answer is E. Okay, the next set is this one. Which of the following could be a pair to the solution to the pair of equations? This means and when you write it this way. So the first thing I'm going to do is write down the two equations on top of each other. So we have 2q minus rt equals 21, and then we're going to add q plus rt equals 36. We're doing that because we can eliminate those. When you add, you're adding this. You're going to get 3q equals 57, so q equals 19. So the only correct answer is the choice that has q as 19, so that would be B. Okay? And the last one again is another absolute value equation. So they just want to know how many solutions, integers, are in the solution set. So basically we do like we did before and set this up like this is what we're looking at. Now I'm going to copy this down without the absolute value. And then since it's an inequality, I'm going to flip the sign and flip the change the sign. So I'm flipping the inequality and changing the sign. And then you just solve for x. So basically, when you solve for x, you're going to get 2x plus, I'm going to write this in fraction form. So you get 2x is less than 7 over 2. Divide both sides by 2, so you get x is less than 7 over 4. And if you want to get an you want to look at it better, this would be about 1 3/4. It acts exactly 1 3/4. And on the same side, we're going to do the same thing. We're going to get 2x plus 12 over 2 is greater than negative 19 over 2. So 2x is greater than, I'm subtract this, so that's going to be negative 31 over 2. So x is greater than negative 31 over 4. So x is greater than negative 7 3/4. So when you look at how many integers are in between negative 7, it's greater than, so we're looking at on a number line, here's negative 8, so here's negative, so we're looking for the numbers greater than negative 7 3/4, or the integers specifically, and less than, I'll put 2 here, 1 3/4. So it's this range. And so let's find out what they are. We have negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. Because these are integers. And so there are 9 integers, so the answer is C. And that's all. Thank you and have a nice day. Bye-bye.